Okay guys, so this will be the review of projectiles, so I'm going to go through this. A particle undergoes acceleration A while moving from point 1 to point 2. Which of the following choices shows the velocity vector v2 as the object moves away from point 2? Okay, so basically we have this guy moving toward point 2. When it gets to point 2, it's going to have this acceleration. And so what we should notice is that once it reaches point 2, it's still going to be going this way, but now it will have a ever-growing velocity in the y. And so what should end up happening is it should drag it down. So it'll be c, like it should start pulling it down. Let's see. Indeed, it is c. Okay, so like if you look here, they're showing that the change in velocity in the y direction is going to be equal to that acceleration times the time. This velocity in the this velocity here is going to stay constant, and then the total velocity is the combination of those two things. Okay. All right. A particle is launched and follows the path back, the black path. Which of these acceleration vectors at the highest point? The acceleration vector is always equal to -10, and so it should be delta. And indeed, it is delta. So if you look, it is delta. Let's see. Carrying on. A particle is launched and follows the black path. Which of the following is the net force at the highest point? Well, this kind of depends. So if we're just talking about the force of gravity, it would obviously be D. If we were including air resistance, it might be C. And if there is a stiff backwind, it might be E. But since we generally don't deal with air resistance, I would say that it is D. The force of gravity is pulling this thing down, so it should just be the force of gravity, and that's what they say, the force of gravity. Kind of ignored this part. This part needs to be ignored. It's just not really all that important. Okay, so this is a heavy red ball is released from rest 2 meters above a flat horizontal surface. At the same instant, a yellow ball with the same mass is fired horizontally at 3 meters per second. Which ball hits the ground first? They hit at the same time. The reason being is the velocity in the x direction does not impact the velocity in the y direction or the speed in the y direction. In fact, it doesn't impact the y direction at all. So you can really shoot it out with whatever speed you want it to. It's not going to affect how it falls in the y direction. And since they both were from the same height, they should both fall for the same time. Okay. This picture right here, if you're looking at it and you're trying to figure out what's going on, this is the velocities when they land. So when they land, the red ball just has a velocity in the y direction, but the orange ball will have a velocity in the y direction and a velocity in the x direction because it was shot out, and that's the reason it's at an angle. Okay. All right, number whatever this one is. A 100-gram ball rolls off a table and lands 2 meters from the base of the table. A 200-gram ball rolls off the same table with the same speed. It lands at a distance. Well, in any of the formulas that we have, mass is not in there, so mass doesn't matter. And so effectively we are just trying to figure out if the mass is important. Since it's not important, it should land at the exact same spot. So it should be 2 meters. Okay? And again, it's 2 meters because it's hitting at the exact same spot as the 100 gram. In other words, these numbers here are irrelevant. Okay? Okay, projectile 1 and 2 are launched over ground with the same speed but at different angles. Which hits the ground first? Ignore air resistance. The one that hits the ground first is projectile 2, and I know this because it doesn't go as high. Okay, so since it doesn't go as high, I don't know, this looks like it's twice as high. Since it doesn't go as high though, because this is how I know that. So time to the top can be calculated using the initial velocity of the y divided by 10, but it could also be calculated using your y equals formula. And so I don't want to do this because you got a quadratic involved, but just to show you what it would be, if you're solving for t and this y is h versus 2h, 2h is going to be in the air for a longer period of time. It's going to take longer to go up and come back down. We can talk about, instead of talking about how long it takes to get to the top, we can talk about the time it takes to fall, because it should be the same, and this makes the initial velocity go to 0 because the velocity at the top is 0. And now you should be able to see that if you do h equals 1/2 times -10 times t squared, and 2h equals 1/2 times -10 times t squared, the 2h will be in the air for longer. So the one that hits the ground first should be about 2. Okay? Projectiles 1 and 2 are launched over level ground with different speeds. Both reach the same height. Which one hits the ground first? These should hit the ground at the same time for basically the same reason. They hit the same height, so they should have the same time in air. A factory conveyor belt rolls at 3 meters per second. A mouse sees a piece of cheese and is directly across the belt and heads straight towards the cheese. At 4 meters per second, what is the mouse's speed relative to the factory floor? It's just a Pythagorean theorem question. You got 4 meters per second this way, and you got 3 meters per second this way, and his speed would be 5 meters per second this way. Good old Pythag. All right. I have a wonderful little drawing for you here so you can see what's going on. All right, a Jeep drives off a building moving at 30 meters per second. Don't ask questions. We don't need to know why it's driving off a building. Maybe it's a James Bond movie. You never know. If it lands with a total final velocity of 50 meters per second, how tall was the building? So, essentially, here's what you know. It's driving off the building at 30 meters per second. And when it hits the ground, it's got a total velocity of 50 meters per second. And so what that means is that in the x direction it's still 30 meters per second, and in the y direction, okay, let me redraw this up here so we can see it. It's going 50 meters per second right here. It's going 30 meters per second in the x direction because that velocity does not change. And so in the y direction, it would be going 40 meters per second because it's a 3, 4, 5 triangle. You can do the Pythagorean theorem. 50 squared equals 30 squared plus Vy squared. Solve, you'd get 40. Now what does this tell us? Well, this tells us that it was going 40 meters per second when it hit the ground in the y direction. So we can use Ay equals Vfy minus Viy over t. And that'll tell us what the time was that it was in the air. So -10 equals -40. It's -40 because it's going down, minus 0 over t, and t ends up being equal to 4 seconds. So if t is equal to 4 seconds, then we can do y equals 1/2 ayt squared plus v0 yt. This is 0. Y is equal to 1/2 times -10 times 4 squared, which should give us 80 meters. Yes, 80 meters. All right, let's see if that's right. 80 meters, what do you know? All right, so that's how that would work. Okay, let's see. Ooh, this one's a fun one. So this is a good one to end on. If a soldier fires a cannon at 25 meters per second at a launch angle of 30 degrees, where would be a really terrible place for an enemy soldier to be standing? So it's, where it's this right here. That's where you wouldn't want to be standing. And then how high does the cannonball go in the y direction? Okay, so if you'll remember, our very first thing to do is to break it into components. So we're going to do that first. So Vx is equal to Vx is equal to 25 cosine 30, and 25 cosine 30 is 21.6, and 25 sine 30 is 12.5. Okay, so now what? Well, this is where it gets a little bit tricky. So what I'm going to do is I'm going to split this in half. Okay, so we're gonna split that in half, and we're going to look at the time it takes to get to the top, and then the time it takes to fall. But those two things are going to be very different because they're going to because it's not from the ground. Okay, so let's first figure out the time to the top. So the time to the top should just be equal to V0 y over 10, which is 1.25 seconds. Okay, that'll allow us to figure out this one. How high does the cannonball go? So we can do y equals 1/2 times -10 times 1.25 squared plus 12.5 times 1.25. So -5 times 1.25 squared plus 12.5 times 1.25, and we find that our ball goes 7.8 meters, but then we have to add in that 60 meters, so it ends up going 67.8 meters high. Okay, so now we know the time to the top is 1.25, but now I need to figure out how long it takes to fall. So if I'm going to find how long it takes to fall, I'm going to have to use the y formula again. This time I'm going to figure out, well, it's falling for 67.8 meters, so I'm essentially just treating it like it's falling. I'm not worried about the first half anymore. So 67.8 meters, it's going down, so it's negative. 1/2 times -10 times t to fall squared plus the initial velocity in the y times t fall. But this is 0 because the initial velocity in the y at the top is 0. And so this ends up being -67.8 divided by -5 square rooted equals the time to fall. So -67.8 divided by -5 square root, second answer. This falls for 3.7 seconds. Okay, now if I'm looking for the distance in the x, I would need to use the velocity in the x times the time total. But the time total in this case is going to be equal to the time to the top plus the time to fall. So our total time would be equal to 1.25 plus 3.7. And so it should be 4.95. So we got dx is equal to 21.6 and t total is 4.95. And it would be a really bad idea if you were the enemy soldier to stand 107 meters away from the cliff. 106.8. Okay, so you can see that I did it correctly. Well, that's a terrible joke, May. Oh goodness. All right. Well, all right. So that concludes the review. Let me know through Remind if y'all need any help. I'll be happy to help. So anyway, have a good one.